What is construction engineering and management? Construction engineers design and execute processes for building and maintaining the infrastructure of our world. The tools of the trade for today's successful construction engineer include the following: strong math, science, and computer skills, creativity, and aptitude for applying science and engineering methods to solve problems, a love of building structures such as bridges, airports, buildings, stadiums, dams, and highways, an interest in working indoors and outdoors, initiative and a strong work ethic, the ability to collaborate with diverse people, good communication skills, and a desire to learn in a constantly changing environment. Students in the Construction Engineering and Management (CEM) program have the opportunity to develop additional expertise in mechanical engineering, environmental engineering, management, building information modeling, and many other options through minors in these fields. Each student completes 3 12-week paid internships before graduating. Internships are normally completed during the summer, with opportunities across the country. Students have worked as locally as their hometown and as far away as Norway. Our students take internship opportunities to work as paid employees in the construction industry and perform duties with increasing responsibilities in field operations, office operations and project management. The CEM program also provides global opportunities, from engineering service trips to Ecuador, fostering international relationships and building structures to better a community, to internship and study abroad opportunities across the world. Because of the unique and hands-on educational experiences of our CEM students, we have a 100% job placement rating for our graduates. What does this mean? Each and every one of our graduating seniors has a job, often receiving multiple job offers before graduation. Careers in construction engineering. Construction engineers have the option of either working in an office setting or out in the field. Oftentimes, it's a combination of both. Some construction engineers focus on the design aspect, while others focus on the actual build phase of each project. There are many career paths to choose from with a degree in construction engineering. General contractors, bridges, roads, buildings, healthcare, data centers, sports facilities. Owners and developers. Mechanical, electrical contractors. Renewable energies. Consulting and design firms. Oil and gas industry. Additional education may be necessary. As your career progresses, you can take your exam to become a licensed professional engineer. With a construction engineering degree and apply since, you can expect to move into senior management within your company. Many construction engineers attain executive positions and even become owners of construction firms. Job responsibilities. As a construction engineer, your responsibilities may include planning and overseeing the construction operations of a project, conducting site layout, scheduling, selecting equipment, organizing the work crew, managing materials, safeguarding the environment, building temporary structures, designing both temporary and permanent structures, checking and modifying plans and specifications for constructability, efficiency, and safety, developing cost estimates and preparing bids, utilizing building information modeling, BIM, software for 3D models. Engineering construction is the sector of the construction industry that is concerned with the design and delivery of industrial plants. It encompasses the construction of structures for the oil and gas industries, both onshore and offshore, power generation, conventional, renewable and nuclear, processing and manufacturing industries, and water and environmental works. In the UK, engineering construction has a clear and legally informed definition, as companies so designated are legally required to pay a training levy to the UK government, but the term is also meaningful on a global scale. Engineering construction is, for example, the concern of both the Construction Industry Institute in the United States and the Associazione Nazionale Impiantistica Industriale (ANIMP) in Italy. Engineering construction is a construction sector of very high global importance. First, in line with the civil engineering sector, it has remained remarkably resilient in the face of the global downturn and the dramatic fall in housing-related construction. As such, it will present a substantive portion of the world's construction activity carried out in the next 10 years. Second, it has a crucial role to play in the enactment of global energy policy in both supply-side and demand-side terms. Engineering construction is the delivery mechanism for the world's energy infrastructure, in the form both of electricity and of oil and gas, and for the industrial processing facilities that contribute a third of the world's annual energy consumption. Engineering construction, certainly at the level of clients and engineering, procurement and construction, EPC, contractors, is a truly global endeavor. Multinational and multicultural projects are the norm, encompassing a wide range of disciplines in addition to civil and structural engineering such as mechanical engineering, electrical engineering, control and systems engineering, structural and pipe fabricators, contractor services and logistics. Engineering construction has a substantial proportion of mega-projects, projects with a delivered value of greater than $0.5 billion. For example, the final cost of Shell's Pearl GTL project in Qatar is estimated at over $20 billion. Even less complex engineering construction projects can still fall into the category of mega-projects. The Greater Gabbard offshore wind farm, commissioned by Scottish and Southern Energy, will cost in the region $2 billion. Stakeholder relationships in engineering construction are different from those exhibited in other construction areas. In some ways, stakeholder interactions are easier to map in engineering construction. Projects have primary users who are usually responsible for commissioning the project. This is unlike the multiplicity of stakeholders involved in the development of a large infrastructural project, such as a bridge. However, the large scale of engineering construction projects often demands complex governance for financing, such as multiple joint ventures, where the role of client and contractor will become merged. Despite the substantive structural and contextual differences between engineering construction and other construction sectors, the implications of these differences for the nature of construction management have not been explored. Issues of governance, complexity, partnering, project management, stakeholder mapping, human resource management, productivity, and constructability all have the potential to need different approaches in engineering construction. Contingency theory would suggest that the different organizational characteristics of engineering construction would result in differences in the way that these organizations need to be managed and, ultimately, in their different management research needs. There is some evidence that this is indeed the case in terms of productivity. Chanka, 2012, Approaches to Risk, Baker et al., 1999, Knowledge, Carrillo, 2004, and Modeling, Sun et al., 2011. This special issue provides an apposite vehicle to explore this premise further. Its diverse contributions act as a conduit to deliver an emergent representation of managing engineering construction and the implications of that representation for research into engineering construction management in the future. Managing engineering construction, the emergent picture. This special issue is differentiated not only by its research contributions but also by its practitioner reflections, as captured in letters to the editor. This engenders the creation of a representation of managing engineering construction that can follow a co-production of knowledge of the type welcomed by Tranfield and Starkey. A distinguishing characteristic of management research is that it engages with both the world of theory and the world of practice. Management researchers can locate themselves at different points in the cycle at different times, but they cannot stay fixed in either the world of practice, without risking epistemic drift, driven by politics or funding, or in the world of theory, without retreating to academic fundamentalism. The problems addressed by management research should grow out of the interaction between the world of practice and the world of theory rather than out of either one alone. Tranfield and Starkey, 1998. The contributions contained in this special issue also span the gamut of projects covered by the epithet of engineering construction. Encompassed in this special issue are contributions pertaining to construction projects in oil and gas, wind and nuclear power generations, combined heat and power plants and pharmaceutical plant construction. In addition to their sectoral breadth, they cover a variety of research approaches from single-case explorations, cross-case approaches and empirically inspired positioning pieces. This special issue brings together 6 research contributions that explore facets of engineering construction management. Koch raises the issues of budget and time overruns and operational underperformance of offshore wind farms. This type of engineering construction is quickly emerging and new to construction management research. Yet Koch demonstrates that familiar and well-known issues from wider construction projects occur even here. Drawing on and criticizing Flyvbjerg's concepts of strategic misrepresentation and reference class forecasting, he calls for the inclusion of technological content as part of the analysis and as part of estimating. He develops a socio-technical variant of reference class forecasting. Closely related to the above study on both focus and methodology, Locatelli and Mancini investigate case studies of 2 engineering construction mega-projects in Europe, the nuclear power plants under construction in France, the 3rd reactor in the Flamanville site, and in Finland, the 3rd reactor in the Olkiluoto site. Since both the projects are over budget and behind schedule, the authors first investigated the origins and then they derived guidelines that will be useful for the delivery of other nuclear reactors and mega-projects. Their analysis is contextualized in the literature pertaining to governance and cost and time forecasting in large projects. The authors used secondary, publicly available data to create their cases and then patterns spotted across these. This analysis indicated that the poor performance of these engineering construction projects may be explained by over-optimistic forecasts, again referring to Flyvbjerg's work, and first-of-a-kind issues. Enlarging the view to best cases in other countries, the authors concluded by stressing the importance of standardization of complex engineering construction projects from the technology perspective and in terms of delivery capability. Brooks, Matter, Bauer and Hagen present an empirical investigation of the actuality of project management continuing professional development, PMCPD, in engineering construction. Using a cross-case analysis of 17 European organizations, they compare the experience of engineering construction companies to wider practice. The authors argue that engineering construction organizations' approach to PMCPD appears less accidental with a greater diversity of delivery and evaluation approaches. Overall, engineering construction organizations are not adopting a systematic approach to PMCPD provision, nor is there evidence of a mechanism for measuring the impact of PMCPD on the performance of the whole project. Fellows and Liu produce a positioning contribution that explores boundary management on engineering construction projects to address the widely criticized issues of fragmentation and performance. The increasing separation of specialist activities accentuates the imperatives of integrating participants through securing commitment and coordination of the diverse organizations and their agents. Engineering construction projects are highly complex and draw on expertise from many disciplines, often located in different countries. Hence, the authors examine interface issues on projects through the insights afforded by boundary management to determine how the variety of interfaces on engineering construction projects is managed and to identify current practices and potential for improvement in the form of a research agenda. Fellows and Liu have undertaken a critical review of theory and literature and applied the constructs and perspectives to the engineering construction context, including addressing project complexity and governance approaches. Their findings demonstrate the use and potential of boundary objects and boundary spanners operating in the complex context of temporary, shifting, multi-goal, power-based coalitions which are engineering construction projects. Those projects are complex and fragmented along all 4 dimensions of those constructs: horizontal, vertical, spatial and temporal. Thus, the boundaries are many and varied but must be sufficiently permeable to facilitate timely and appropriate responses to changes in the environment and other parts of the project system. Conclusions reinforce the critical importance of informal project systems and that many project performance requirements are emergent and that the project participants co-evolve to yield self-organizing governance. Development and use of appropriate boundary management, objects and spanners, foster commitment, coordination and cooperation, integration, even with participants retaining their individual goals, and so promote non-zero-sum performance gains. Pasquire delineates the implications of adopting a lean perspective for engineering construction. Pasquire uses the Gibson Report as the starting point for both defining engineering construction and reviewing its current problems in the UK. From this, she conceptualizes 12 factors that differentiate engineering construction from other forms of construction. She then posits that adopting a lean construction perspective may be used to characterize this kind of construction as a form of production and elucidate its problems. However, she argues that many challenges remain in adopting the solutions this approach presents. She proposes that current perceptions about commercial arrangements, motivation and incentivization need to change, and a new conceptualization of procurement and project management needs to be developed to benefit from the advantages following from this approach. Greenwood and Gledson explore the problems associated with the efficient scheduling of resources within large-scale engineering construction projects. Empirical data were collected from a case study of the recent construction of a combined cycle power plant in Iran. Parallel testing was undertaken of two approaches to calculating an optimum schedule. A manual approach using a heuristic algorithm was compared with that of the standard software package used by the contracting organization. The manually applied heuristic produced superior results. Consequently, the authors recommend that managers should challenge standard solutions and that software suppliers should look to integrate improved techniques into their applications in order to improve the current solutions that are heavily relied upon by industry practitioners. This is especially important in the light of the productivity problems that have been identified in the UK and elsewhere. Practitioner reflections provide an interesting juxtaposition to these research contributions. Reflections have been contributed by a program director operating in the energy sector and working for one of the largest global providers of brownfield services to the oil and gas industry, Maplesden, a chief executive officer of a national training and skills provider in engineering construction, Edwards, a subject matter expert on project performance for a large global petrochemical company, Podesta, and an individual responsible for developing the project management capability for an oil and gas multinational, Oliver. A common theme in all of these contributions is the need to recognize the importance of relationships in managing engineering construction and to emphasize the skills required to align stakeholders between networks, especially where the network crosses organizational boundaries. Practitioner contributors also focus on developing the competencies to deliver engineering construction projects in an attempt to overcome their perception that managing engineering construction is often seen as an accidental profession. Although the sample of practitioners is, of course, self-selecting, it is interesting to note the awareness and the willingness of these practitioners to engage with the research community in understanding how to manage engineering construction. Their identification of new knowledge that they feel would contribute to the better management of engineering construction is of note. Their focus is frequently orientated around what may be termed human resource issues and is tangential to the existing streams of construction management research. They are interested in ways in which to construct capability at a whole organization level. They are interested in why engineering construction, in line with other construction sectors, is unattractive to many potential entrants. They are interested in developing people's abilities to create and sustain relationships in projects. When considering these contributions in their entirety and using them to paint a picture of managing engineering construction, it is interesting to note that contributors have not identified new constructs pertinent to managing engineering construction but rather utilize existing discoveries and debates, although amplified in certain contexts. Thus, in reviewing the performance of engineering construction projects, both Locatelli and Mancini and Koch find evidence for the same kind of failure to forecast appropriately as has been in evidence in other civil engineering or transport infrastructure projects. They do differentiate, however, the reasons for that misrepresentation from those articulated in other types of projects. Unsurprisingly, both research and practitioner contributors demonstrate an acute awareness of the boundaries within engineering construction projects, which they argue are greater in number and in depth, and the need to transfer knowledge and develop relationships to span these boundaries for the benefit of the project. Maplesden, Locatelli and Mancini, Oliver, Edwards, Podesta and, in particular, Fellows make reference to networks of relationships within engineering construction. A focus on the importance of the front end of engineering construction activities also echoes that preoccupation found not only in construction management but also in project management. Thus both the contribution of Greenwood and Gleidson and that of Maplesden emphasize the importance of front-end planning, and Podesta and Pasquire discuss how a lean perspective may provide the rationale to promote whole project life benefits as an effective trade-off against the early expenditure of forwarding engagement. Finally, contributions combine to give a picture of highly unsystematic development of the skills and competencies needed to manage engineering construction. This is evident in the analysis of Brooks et al. And in practitioner reflections. Implications for future research. Creating a picture of managing engineering construction allows a tentative form of a research agenda for engineering construction to be developed. However, attempting this immediately calls into question the wisdom of this endeavor. An a priori widely accepted manifestation of a construction management agenda has not been articulated. Although attempts to generate these at a whole sector level have historically been undertaken, for example Betts and Wood-Harper, 1994, more recent allusions to generating a research agenda seem to be confined to the particular attributes under investigation by the researcher, for example a construction skills agenda by Chan and Dainty, 2007, a construction identity agenda, Brown and Fua, 2011, a governance agenda, Winch, 2001. Exhortations relating to research agendas that are made at a construction sector level focus on the need to develop more critical research stances regardless of the aspect of inquiry, Green and Harty, 2008, Phelps and Horman, 2010. By involving the voices of practitioners in this special issue, and by deliberately positing this activity under the aegis of co-creation of knowledge, this critical agenda has not been followed. Rather, the generation of a research agenda has been undertaken from the voices of researchers and practitioners that relies on Pettigrews, 2011, premise of the validity of practice and impact in guiding future research. The diversity of contributions precludes anything other than a speculative premise on the contents of a research agenda for engineering construction. However, the confluence of researcher and practitioner perspectives contributes to a tentative reassurance in the validity of pursuing such an endeavor. The constructs raised by contributors are familiar concerns in the wider field of construction management, but the emphasis on and preoccupation with a network of relationships between that runs throughout the contents of this special issue is of particular note. This concern can be found, for example, in the reflections of Locatelli and Mancini that networks need to be stable across mega-projects in order to benefit from the knowledge generated in that project. It can also be detected in Fellows and Liu's discourse on boundary crossing between project networks. It is given a strong voice in the pleas of Oliver, Maplesden, Edwards and Podesta and the need to understand and align these relationships. This would suggest that one of the most fertile fields of endeavor for future attempts to explore engineering construction management will lie in the ability to capture and characterize relationship networks. Construction engineers, salary, career path, job outlook, education and more. Construction engineers manage construction projects, ensuring that they are scheduled and built in accordance with plans and specifications. These engineers typically are responsible for the design and safety of temporary structures used during construction. They may also oversee budgetary, time management, and communications aspects of a project. Education required. Civil engineers need a bachelor's degree in civil engineering, in one of its specialities, or in civil engineering technology. Programs in civil engineering and civil engineering technology include coursework in math, statistics, engineering mechanics and systems, and fluid dynamics, depending on the specialty. Courses include a mix of traditional classroom learning, work in laboratories, and field work. Programs may include cooperative programs, also known as co-ops, in which students gain work experience while pursuing a degree. Job outlook. The projected percent change in employment from 2016 to 2026, 11%, faster than average. The average growth rate for all occupations is 7%. Advancement. Civil engineers with ample experience may move into senior positions, such as project managers or functional managers of design, construction, operation, or maintenance. However, they would first need to obtain the professional engineering license, because only licensed engineers can assume responsibilities for public projects. Licenses, certifications. Licensure is not required for entry-level positions as a civil engineer. A professional engineering license, which allows for higher levels of leadership and independence, can be acquired later in one's career. Licensed engineers are called professional engineers. UP can oversee the work of other engineers, approve design plans, sign off on projects, and provide services directly to the public. State licensure generally requires median pay. How much do civil engineers make? $83,540 annual salary. $40.16 per hour.